Inshallah, in today's class, we are going to do the questions on Newton's law of cooling. Now, let us first see what is the statement of the Newton's law of cooling. The rate of change of temperature is proportional to the difference of the temperature of the body and that of the surrounding temperature. It's very easy to understand. If the surrounding temperature is very cool, less, then the change of temperature of the body will be fast. The body cools fast, its rate will be high. Suppose if the surrounding temperature is nearly equal to the temperature of the body, or difference is less, then the fall of the temperature of the body will also be less. That is directly proportional to the difference of the temperature of the body and the temperature of the surrounding. Let me write the mathematically how we can write. Suppose theta is the temperature of the body, theta naught is the temperature of the surrounding. So according to the law, what is there? The rate. Rate means d theta by dt. What does it means? It means the rate means differentiation with respect to time. Rate means differentiation with respect to time. So the rate of change of temperature is proportional to the difference of the temperature of the body, difference of the temperature of the body and temperature of the surroundings minus theta naught. So if we take out the proportionality, we will get the constant. We use the constant minus k into theta minus theta. The constant we are using is minus k because the temperature is decreasing. So let me do one thing. Let me use differential equation method. Separate the variables, bring theta here and t here. We can do like this. D theta by theta minus theta naught equals to minus k into dt. Now integrate both sides. Integration of 1 divided by theta minus theta naught into d theta equals to minus k into integration of 1 dt. Now integration of 1 by x is log x. Integration of 1 by x is log x. So this will be log of mod theta minus theta naught equals to minus k into integration of 1 is x. So is this here t. So integration of 1 will be t plus, suppose we are writing c. Now the next step, watch carefully. There is a theorem. The definition of log is, suppose log x equals to n. We are having here base e. If you take out the log here, then this base will go here. It will be like this, e power n. So using the definition of this log, let me take out the log here. Here we are having the base e. So take out the log. What is left here? Theta minus theta naught equals to e power minus kt plus c. We can write like this. Theta minus theta naught equals to e power minus kt into e power c. E power c. Let me take e power c equals to capital C, suppose. Now this will become theta minus theta naught equals to c into e power minus kt. So this is the mathematical derivation of the Newton's law of cooling. Let me use this. Theta means the temperature of the body, theta naught the temperature of the surrounding, t means time, and c and k are the constants here. So in the questions, I am not going to derive this every time. We are going to use this direct formula in the questions. What is the direct formula we can use? Theta minus theta naught equals to c into e power minus kt. So let me do a few questions based on this formula. Now see here, I wrote a question on the board. A body kept in air with temperature. Generally the surrounding temperature will be air. Generally we will have air. So air temperature, that is theta naught. Theta naught is 25 degrees Celsius. The body cools from 140 to 80 degrees. Initially starting the temperature is 140. But after 20 minutes the temperature reduces to, 20 minutes the temperature reduces to 80 degrees Celsius. Find when the body cools to 35 degrees Celsius. You see, the question will be very easy. Let me change it. Generally we'll have three cases. Case 1. Always in case 1 you take initially, at the starting, initially. So what will be the initial time? Time will be 0. Always the initially when you start, that means it's at the time of starting. So at the time of starting we take always time equals to 0. So what is the temperature? Temperature falls from 140 to 80. So the initial temperature is 140. initial temperature is 140. So we got this one. Okay, now let me use this too. In the question you keep and also we are having theta naught is the temperature of the surrounding air. The air temperature is 25 degrees Celsius. Now let me substitute this in the question. Let me substitute this in the formula. Theta minus theta naught equals to c into e power k. Theta is 140 minus theta naught is 25 degrees Celsius. Sorry, theta minus theta naught equals to C. We don't know C, right, as it is into E power minus K into T. So the value of T is 0. See here, E power 0 will be 1. 1 into C will be C. Therefore, we get the value of C equals to 140 minus 25 will be 150. So in the first case, we got the value of C. In the first case, we got the value of C. Now let me do one thing. In the second case, case 2. Case 2. Always do like this. Huh? Case 2. The temperature changes from 140 to 80 in 20 minutes. So in case 2, what will be the time now? After 20 minutes means T equals to 20 minutes. The temperature is 80 degrees Celsius. The temperature changes from 140 to 80. That means the case 2, the temperature will be 80. The time taken for to drop the temperature is 20 minutes. So again, let me substitute now. What is theta naught? Theta naught will be always the surrounding temperature, that is 25 degrees Celsius. Now again, you substitute in the formula. Theta minus theta naught equals to C into e power minus kt. Now here we are having theta is 80 minus theta naught is always 25 equals to C. We got here C as 115 into e power minus k into t. The value of t is 20 minutes. The value of sorry, so what will be here? 80 minus 25 will be 55. 55. Now bring this 115 here by 115 equals to e power minus 20k. E power minus 20k. So let me cancel this one. 5 1 5 1s, 5 2 5 3s. Therefore you see here e power minus 20k equals to 11 by 23. 11 by 23. Let me change a little bit here. So you do one thing. If we take, see, we can write like this: e power minus k equals to 11 by 23 power. If we bring 20 here, from here to here, it will become 1 by 20. I'm noting this as 1. Let me note this as 1. Watch here. If we bring this 20 here on the other side, it will be 11 by 20. 11 by 23 into 20. If you bring in on the other side, it will be 1 by 20. So we got the value of e power minus k. We got the value of e power minus k. Now case 3. Case 3. Now the case 3 will be always the question. Case 3 will be always the question. What is the question? Find when. Find when. And means time equals to how much? When means time. Find when the body temperature will become 35 degrees. The body temperature will become 35 degrees. So again, let me substitute the values here. Theta minus theta naught. Theta naught is 25 equals to C. C we got 115 into e power minus k into, we have to find the value of t. We have to find the value of t. Now let me continue here. This is 10. Bring this 115 here by 115 equals to, you see here we can write like this: e power minus k whole power t. Whole power t. Now see here, this is 5 2s are 5 2s are 5 3s are. Okay. So let me write like this here: 2 by 23 equals to e power minus k. We already have write the value, written the value of e power minus k. E power minus k, the value of e power minus k is 11 by 23 whole power 1 by 20, and whole power t means you t will get here, t will get here. So whenever we have to find some value on the base power, whenever we have to find the value on the power, suppose this is, apply log on both sides, it will be easier. So log of 2 by 23 equals to log of 11 by 23 whole power t by 20. T by 20. So let me do one thing. This will come here. T by 20 will come here. I'm writing like this: t by 20. This t by 20 will come here. T by 20 log of 11 by 23 equals to log of 2 by 23. Now lastly bring these values here. So t equals to 20 is in the denominator here. If you bring this here, it will be in the numerator. 20 log 2 by 23 divided by log of 11 by 23. So we will get this from the calci. We will get this from the calci. Okay. You see here, I'm writing. Now see here, first thing is let me take the divider. Just wait. Let you take first the divider symbol. So what we are having here 20. So 20 into, I'm using ln log. Okay, because here sometimes we use e also. No? Here whatever log you use, you will get the same answer, but I am using ln. 2 divided by 23 bracket close. What is in the denominator? In the denominator we are having log ln 11 divided by 23. So let me see the answer. So the answer is 66.24. So we are writing in the minutes now. So after 66.24 minutes, the temperature is reduced to 35 degrees Celsius. So let me do one more question based on this. Write the remaining answer after 64.24 minutes. See here, next question. A body is originally at 80 degrees Celsius and initial temperature is 80 degrees Celsius and cools down to 60 degrees Celsius in 20 minutes and cools down to 60 degrees Celsius in 20 minutes. If the temperature of the air is 40 degrees Celsius, if the temperature of the air is 40 degrees Celsius, find the temperature of the body after 40 minutes. The same question, same method. Let me start. Always we will have three conditions here. In the case 1 and case 2 will get the values, and the case 3 will be the question. According to the Newton's law of cooling, theta minus theta naught equals to C into, in the case 1 we use the initial values. Initially we write initially. What will be the value of time? 0. The temperature initially is 80 degrees Celsius. After that it becomes 60. So initial temperature is 80 degrees Celsius. And temperature of the air will be constant. This is 40 degrees Celsius. Theta naught, sorry. Temperature of the surrounding is theta naught. Now let me substitute these values in the formula. Theta minus theta naught. 80 minus 40 equals to C we don't know. E we don't know, minus K into, initially time is 0. So this is e power 0. It will be 1. 1 into C, C. Therefore we get the value of C equals to 80 minus 40 is 40. So we get the value of C. Now case 2. Case 2. In the case 2, the temperature changes to 60 degrees Celsius. From 80 to 60 degrees Celsius. So the case 2 is, the temperature changes from 80 to 60. So case 2 is 60 degrees Celsius. After time 20 minutes. After time 20 minutes. After time 20 minutes. So this is case 2 again. Now we have always theta naught will be the temperature of the body surrounding, sorry, air. This will be, again let me substitute the values in the formula. What is the formula we are having? Theta minus theta naught equals to C, already we got C, into e power minus K into T is 20. Okay, let you find e power minus K from this. This is 60 minus 40 is 20. Sorry, 60, yeah, 40 is 20. Bring this 40 here by 40. We can write like this, e power minus K whole power 20. E power minus K whole power 20. This is 1 by 2. So e power minus K whole power 20 equals to 1 by 2. If you bring 20 on the other side, it will be 1 by 20. So we get the value of e power K minus K equals to 1 by 20 power 1 by 2. 1 by 2, sorry, 1 by 2 power 1 by 20. So we got the value of C, we got the value of e power minus K. And now the case 3 will be the question. What is the question asked here? So what is the question? When find the temperature. Find the temperature means theta naught, theta, sorry. Find the temperature. Find the temperature of the body after time 40 minutes. Now again let me substitute this in the formula. What is the formula? Theta minus theta naught C into e power minus kt. Now let me substitute theta here. We have to find the theta. We don't have theta, so right? Theta as it is minus theta naught is 40. C, we got the value of C is 40 into e power minus k in power t, sorry, t means 40. So you see here we can write like this, theta equals to minus 40 on the other side plus 40 plus 40 into, we can write like this, e power minus k whole power 40. So we got the e power minus k, just now we got 1 by 12 power 1 by 20. So we see here, let me substitute this e power minus k here. So see here, 40 plus 40 into, the value of e power k minus k is 1 by 2, 1 by 2 power 1 by 20. Again power is 40. So we can cancel this 20 ones or 22. So 1 by 2 square will be 1 by 4. So this will be 40 plus 40 into 1 by 4. 40 into 1 by 4. You can cancel. If the numbers are difficult, we have to use calci. But here it's very easy, no? 4 ones are 4, 10s are 10 plus 40 is 50. 10 plus 40 is 50. 10 plus 40 is 50. So the temperature of the body after 40 minutes will be, temperature of the body after 40 minutes will be 50. Now let me write the, therefore the temperature of the body after 40 minutes is 50 degrees Celsius. Now let me have some another concept and that based on other questions, inshallah. This is also in the same method, everything will be same here also. See here, law of growth. Law of growth. Sometimes as the time increases, the substance also increases, like bacteria. As the time grows, time increases, the bacteria also increases. So we say law of growth. Like population, the time increases, days increases, the population also increases. And the same way, sometimes law of decay. Sometimes as the time increases, the substance decreases. As the time increases, the substance decreases. For instance, some animal died, it decomposes. So if the, as the time increases, the body, the substance increases, we say growth. As the time increases, the substance decreases, we say decay. Like radioactive substances, there we have decay. So for here, you see here, the rate of change of, the rate of growth of the substance is proportional to the amount of the substance at that time. Amount of the substance at the time. No need to derive everything, just by heart the formula. For rate of growth, we use n equals to c into e power kt. N equals to c into e power kt. Same for decay, just we write minus kt. N equals to c into e power minus kt. For decay, we use this minus kt. For growth, we use plus kt. N means the amount of substance, and c and k are the constants, and t is the time. Okay, t is the time. So let me do same like Newton's law of cooling. Here also we will have the same method of doing the questions. So let me do one two questions on this. So let me do one question. See here, the number n of bacteria in a culture grew at a rate proportional to n. That is law of growth. The value of n initially 100 and increased to 332 in 1 hour. What was the value of n after 1.5 hours? Same questions like that of Newton's law. First, we let you write law of growth. Law of growth. So what is law of growth we are having? We are having law of growth is n equals to, law of growth is n equals to c into e power kt. Okay, let me substitute the values one after one. Now initially, let me see. Same case one is initially. Always initially we take time equals to 0. The bacteria initially was 100, so let me write 100 here. Now substitute here. The value of n is 100. So 100 equals to c into e power k into t is 0. So e power 0 will be 1. Therefore, we get the value of c as 100. First step. Now case 2. Case 2 is after 1 hour. That is t equals to 1 hour. After 1 hour, the bacteria is 332. 332. Now let me substitute again in the formula n. Now we are having n here 332 equals to c, we got 100 into e power k into t is 1. T is 1. So we will get the value of e power k. Bring this 100 here. So e power k equals to 332 by 100. Now we can write e power k equals to 3.32. So we get the value of e power k here. Now the third step will be about the question. What is case 3? Case 3 is, what is the value of n? What is the value of n? What is the value of n after 1.5 hour? 2 ones are 2 plus 1, 3 by 2 hour. Now again let me substitute the formula n equals to c into e power kt. Now we have to find n equals to c, we got already, c is 100 into e power k into t. The value of t we can write like this, 3 by 2. So the value of k, 3, t is 3 by 2. Now we already got the value of e power k as 3.32. Let me substitute here 3.32. So n equals to 100 into 3.32 to the power of 3 by 2. So we will get this value in the calci. We can get this value from the calci. See here, let me start just now. See here, what we have to write, 100 into 3.32, 100 into 3.32. Here we will get the power 3 by 2. 3 by 2 means 1.5 we can write. So this is 3 not, we got this one as 604.9. Approximately we can take what the value we can take, we can take 605, because bacteria means it should be a natural number. So we can write the number of bacteria after 1.5 hour will be 605. Now let me do one more question. If 30% of a radioactive substance disappear in 10 days, how long will it take for 90% of it to disappear? If 30% of a radioactive substance disappear in 10 days, how long will it take for 90% of it to disappear? See, because this is decreasing, so we can say this is law of decay, because radioactive substance decreases, it reduces, no? So we can use rate of decay. Now same initially. Now see here, there is nothing given for initially. So let me take initial amount as x. Initial amount as x. So time will be always 0. Time will be always 0. Now let me substitute this in this value, n. Let me substitute n equals to x equals to c. The value of c we don't know, e power minus k into time is 0, e power 0 is 1, therefore c equals to x, we got c equals to x. This is initially. Now case 2, the of the substance disappear, 30% of the substance disappear, you see here. So how much is left? 70% is left. So case 2, you see here, 30% of substance disappear. That means, that is, amount left is 70%. So x equals to 70%. 70% means x by 100. Okay, so let me write like this, 7x by 10. Okay, now again, what is the time here after 10 days? So t equals to 10 here, 10 days. Now let me substitute again the formula n. N is 7x by 10 equals to n equals to c. C we are having here x, we got x into e power minus k into t is 10 here. See, x will get cancelled. Let me write this 0.7. You see here, we can write like this, e power minus k power 10 equals to 0.7. Now if we bring this 7 here, it will 10 here, it will be 1 by 10. So we'll get the value of e power minus k equals to 0.7 power 1 by 10. Now let me note this as 2. Now case 3 will be the question. How long will it take for 90% to be disappear? So case 3 is, how much is left? 90% disappear means the amount left will be 10%. So this will be 10 into x by 100, because x is the initial amount. So we can write this as 0 1 by 10x. Okay, 1 by 10x. Now let's substitute n equals to c into e power minus kt. Now n we are having 1 by 10x, c we are having x into e power minus k. We can write like this, whole power t. So this x-axis will get cancelled. So 1 by 10 equals to 1 by 10 equals to, we got the value of e power minus k as 0.7 power 1 by 10 whole power t. We can write like this t here. Now apply log here. Log of 1 by 10 equals to log of 0.7 power t by 10. I'm writing here. See here, this t by 10 will come here. We can write like this. T by 10 equals to, what is left here? T by 10, sorry, log 0.7. T by 10 log 0.7 equals to log of 1 by 10 means 0.1. Log of 1 by 10 means 0.1. Now bring the other values. What will be t here? T equals to, bring 10 here. 10 into log of 0.1 by log of 0.7. T equals to log of 0.1 into 10. You see here, let me use the dividend. Divide as the symbol here. 10 into log, I am using ln, 0.1 divided by ln log 0.7. So we'll get the value of t. So t will be approximately equals to 64.5 days. The question is given in days, so we have to write days. If the question is given in hours, we will write hours. Therefore, after 64.5 days, 64.5 days, the amount left will be 10%. That is, 90% is disappears. So in this class, we have discussed about the law of growth, law of decay, and Newton's law of cooling. I request to do some more questions for practice from any textbook. Inshallah, we will continue in the next class. Some topics which are not for some universities, but for some universities we have the topics. Inshallah, we will continue in the next class. Inshallah, Riccati's principle and other, inshallah, in the next class. Inshallah.